Hello and welcome.
Hi guys. Okay, so Adam, I think we should start. So guys, firstly, thanks for joining the noise dosimetry webinar today through Svantek UK Limited. You're here with myself, Aaron Priestley, the Health and Safety Product Manager, and also my colleague Adam Marchak, based in Poland. Adam works very closely with with the programmers and also the developers in terms of the equipment and also the software, and he acts as a go-to between the UK and Poland. In terms of kind of our offering today for the guys participating, if you go through our health and safety website through shop.axoff.co.uk, you are able to obtain 10% off discount on our noise dosimeters. Just simply use the webinar 10 promotional code and you should be good to go. What I'm going to do now, I'm going to pass over to Adam, who can provide the demonstration to you. And yeah, any questions, feel free to give us a shout at the end of the call.
All right, thank you very much for that, Aaron. Thank you for the introduction. So as Aaron said, my name is Adam Marchak. I work out of Svantek, Poland. I'm the regional sales manager. I take care and help and try to support the best way I can our great colleagues in Svantek UK. Now I'd like for us to go through this little presentation that I've done for you today. And as Aaron mentioned, I believe there's a functionality where you can answer or ask questions during the webinar in the interface, and we'll try to get back to you on that. For you that are new to our company, for you that are new to our organization, Svantek has been around for approximately 30 years, a little bit over that now, in the field of sound and vibration. This is the exclusive field that we work with. We do not do any dust, gas, other health and safety. We work with sound and vibration. We were established 30 years ago, and we are still under the same leadership today. The company is family owned, and we keep close to our values, where we really strive for excellency within this sound and vibration field. We have been since then setting the trends in that field. We have been setting the trends when it comes to functionalities for sound level meters, for noise dosimeters, for environmental noise monitoring stations. And this has been recognized. This has been recognized by the market. We are loved by the best. We have clients such as NASA, European Space Agency, the Chinese Space Agency as our clients within our client base. On the right-hand side here, on the picture, you can see a picture of the Svantek SV102A Plus Class 1 noise dosimeter that is currently mounted on the International Space Station. It is there constantly, recording the noise and checking the noise exposure that the different astronauts are being exposed to. We're also being certified for other missions with NASA. On the left-hand side, I don't know if this is mirrored to you. On the left-hand side, I would like to show a quick video where we'll be showing you guys a little bit of how a different dosimeter that we can talk about today is applied. So as you can see here, we have an astronaut here in the Chinese Space Agency wearing a Svantek SV104 BIS dosimeter. They have been very happy with this equipment, equally to NASA. Well, this proves to you that our equipment can be used in zero-G gravity fields. It can be used on Earth. It has been really well validated in different fields. But we're not here to plug our products exclusively. We're here to talk about noise dosimetry. We're here to talk about noise dosimetry, why we perform noise dosimetry measurements, what we are looking after, and how we do it in a good and reliable way. So starting with the first part, the why. Why are occupational noise exposure measurements important? Why do we need to perform them? And why it is important for you as a health and safety manager to make sure that the employees under your care are constantly being watched for overly exposure to noise? Well, as you can imagine, work conditions ever since the industrialization have been improving radically, from very extreme cases of exposure to gas, the possibility of being killed in work, for very spectacular danger, such as a mine falling apart, an explosion where there are a lot of chemical substances. We have now been able to reduce all of them to a minimum. You rarely hear about people dying on the job anymore, because we have been so good when it comes to really minimizing the risks when it comes to work. However, one major field that we still get a lot of complaints about, and hazardous condition that we're not really taking care of as we should, is noise. And noise-induced hearing loss is one of the most major occupational diseases worldwide. In the US, it is estimated that over 30 million workers are exposed to dangerously high levels that will cause problems and can lead to permanent hearing loss. So in very well-developed countries like the US or the UK, where the National Society for Clean Air and Environment Protection claims that over 1 million people are in the danger zone for losing their hearing because of occupational noise exposure, even in those very much developed countries, we still have this problem. And this problem requires to be addressed, because you may lose more than 50% of your inner hair cells in the cochlear before you even can sense the difference. Okay, what does this mean? Well, on this picture we're seeing right here, on the left-hand side, we have a healthy inner ear. These are the hair cells that take care of the vibrations in air. So the noise or the sound is propagating through air, putting air particles into vibration. Those vibrations will then go into our ear, will be affected by these hair cells that will then transform them into electrical signals to be picked up by our brain. Before we can sense a change in our hearing, as a person, we can lose up to 50% of them. And at that point, it's too late. And with these hair cells, it's like with any other hair cells, especially for us males. You will lose them as time progresses. So if you lose 50% of your hair cells within that inner ear, and then you start to take care of it, you're in a very big danger zone that you will lose your hearing as you progress in age, all right? And failure to protect in good time will cause damages that you cannot mend medically or surgically. You will lose one of your most important senses, which is the sense of hearing, and you will not be able to get that back. And obviously, there is a liability here in terms of compensation, in terms of benefits, and you don't want to pay that out, sure, but that's not the main thing. You do not want your employee to be losing your hearing on the job. This is not a disability that you should have to deal with in today's world. So the question is, how can we correct, assess, and protect against hearing loss? The first step is to prepare, just to think about it, just to imagine what a dangerous level can be. And the HSE has a very cool, simple assessment tool or simple assessment table that I'm showing here. So if you have a workplace where noise is intrusive, but normal conversation is possible, let's say like in a cafeteria or a restaurant, a loud one. So you are able to speak with your colleague without raising your voice, but there is noise that is intrusive. You are affected by it. Well, that means that the probable noise level is about 80 dBA. If you have to shout to someone that is 2 meters away, let's call it a mechanical workshop or a mechanic shop where you fix your car, and in order to be able to speak to someone that is 2 meters away, you need to raise your voice, where you're most likely exposed to 85 dBA exposure. So this is the equivalent level, and that means that a risk assessment will be needed if that noise is there. So this is the constant noise level for more than 2 hours. If you have to shout to someone that is 1 meter away, so now we're in really a noisy restaurant, we're in a bar, in the evening, 90 dBA is the expected noise level. Well, 45 minutes, that's how long you will be able to be in that environment before you need to start thinking about the ability to fix that. So we also have these examples of typical noise levels. The dB logarithmic scale is not so easy to understand for people that are not involved in acoustics, but just to show you that the difference between 80 and 100 dB is it's very much a big difference. 80 dB in our table here, that's a tractor cab. You're sitting in your tractor driving around. That's the level you're exposed to. Again, remember the simple assessment tool about HSE. 80 dBA is the noise level that is just a little bit over the annoyance level, where 100 dB, that's a chainsaw. That's a chainsaw. That is something that can start physically hurt you. You are exposed to that. It is too much for you to handle. Well, so this is the simple assessment, and this is the first good step. Start thinking about it. Start thinking about, should I be protecting my workers? Is this too much? But the second stage of that assessment is a measurement. So the question is, with today's tools that are available to us, with our smartphones, with our microphones, can we just go ahead and take an app and start measuring it? Where Chris Steele here, who is a known specialist within the health and safety in the UK, has been asked what the position of HSE is. And it clearly states that you cannot perform measurements and assume that you have a reliable and good assessment unless you have a device that conforms to standards, to specifications, to a methodology that is really defined. But we're in luck here. We're in luck because as of 2004, the World Health Organization outlined the risks, factors, and the methodology for how to perform a noise exposure assessment. What do I mean by that? Well, before that, obviously, we did have other methodologies, but it was found that the sampling method is not good. It was found that the dosimetry method is the best way to go about it. Why? Well, you have an exposure meter that is personal to yourself, all right? So you put it on yourself, you put it on as close to your ear as possible without having to compromise with your comfort. You put it there and you start to measure the exposure over the entire course of the day, all right? So imagine this. You are working in a dental office and you do these scans, right? These x-ray scans, and you have a dosimeter. It's the same thing with noise exposure. If you're measuring your x-ray dose that you're exposed to every day, it means you have to be carrying it around all day, not only when performing the tasks, not only when you're on the break, all day. Only then do we have a very good 8-hour sample to be able to distinguish whether we performed a good measurement and whether we can make a good assessment that will tell you if we are overly exposed to sound or noise, should I say, and if some action requires to be taken. So the World Health Organization just created guidelines, methodologies. Now you will have local regulations. You will have, as you have in the US, OSHA here in conservation program, OSHA, PEL, ACGIH. There are different organizations that have different approaches, but the key element is the same. The personal exposure meter approach is the best one to have in order to be able to do a very reliable assessment. The microphone should be on the shoulder where that is most exposed to the noise. So if you have a stationary worker that is sitting next to a machine and that machine is on his right-hand side, you should be putting that dosimeter on his right-hand arm because you want to have the worst case effect. Now, you should have that located to your ear as close as possible. Obviously, the shoulder is a good place to put it because you then don't have to wear it on your head, right? So we understand the methodology, we understand how to perform it. So let's go into detail. So how should a correct and good noise dosimetry measurement be performed? What are the steps? Number one, per the old school way of doing it. You do a pre-measurement briefing with your test subjects. So if you're putting this on an employee, you should brief him on what to do and what not to do. Do not play with this device. Do not fiddle around with it. Try to protect it from mechanical shocks. You should also try to minimize the unrelated noise exposures, like screaming into the microphone, laughing into the microphone. Try to minimize that. Obviously, before you start the measurement, you also need to do a calibration, right? So you perform a calibration on site using a class 2 calibrator or better, and you do that before you begin your measurement. Then number 2, measurement. Supervise, measure, and observe, all right? As a health and safety specialist, you should ensure that the measurement is being performed correctly. If you're given the possibility, you can check off the levels, see that everything is being measured as it should. You should note any artifacts that you have seen during the measurement, and you should exclude them in the post-processing session. So step number 3 here, right? We have done our briefing, we have performed the measurement, we have done our samples, we now are in the post-processing stage, and that will lead us to the fourth part of this, which is conclude a report. Create a report, make a conclusion based on reliable information of the highest reliability when it comes to measurements. In order to provide the correct assessment, we must ensure only valid data is taken into consideration. So pre-COVID, we would have a normal supervised session where the briefing was possible, supervision observation was possible, post-processing based on notes that you made during the measurement, all of that was possible. But then COVID came. We saw that a lot in the US, we saw that a lot in other countries where health and safety specialists that were not based on that site were not allowed to come there anymore. You were not allowed to enter that facility because you yourself were a health risk to the employees. So we start seeing more and more unsupervised noise dosimetry session. What do we understand for that? An unsupervised noise dosimetry session is a session where you're being sent a device with instructions, but there is no health and safety professional on site to overview, to supervise, to educate on the performance of that measurement device. So in that kind of scenario, we would have a pre-configured dosimeter without the ability to brief and install on site. The measurement would be performed without any supervision, so you have no ability to make notes, you have no ability to make sure that artifacts are minimized, you have no ability to really brief the person on site unless the foreman does it. So when you came to step number 3, which was post-processing and analysis, you had no clue what to exclude, what to include, whether a measurement was performed in a correct way or not. And is that a problem? Well, ISO says it is. You are to remove uncertainties and perform some kind of error handling as part of your dosimetry measurement. What does that mean? You need to remove false contributions, as it says here, from wind, airflows, or impact, mechanical shocks to the microphone. You need to be removing non-typical noise sources, speech, music, alarm signals, and non-typical behavior that will affect a conclusion that should be true for an entire year or a different period, and not only for that day. You need to have that information to be able to make that kind of distinction, right? You need to be able to know if the huge impulse that you saw here was an actual noise impulse, an explosion or metal to metal, or if it was just someone carrying this around, punching the microphone, walking into walls and whatnot. This is an ISO standard requirement that you do remove uncertainties to be able to perform and make a good assessment. And it has not been easy to do so. It has not been easy to do so, but with our new validation tool, you can now perform that in a very fast and very easy way. So how does that work, and what do I mean by that? Well, the Svantek dosimeters have audio recording capabilities. So if you're on a site where this is allowed, where you can perform audio recording capabilities, you are able to record all noises above a certain threshold level and then perform an analysis by simply listening to them and distinguishing between a noise source that is a valid noise source, that is an everyday noise source, that is a noise source that you will be exposed to on the job, versus exactly what, as we had in the ISO standard, alarms versus laughing into the microphone, screaming into the microphone. That's number one. Second feature that is unique to the Svantek dosimeters is the mechanical shock sensor. A small accelerometer within this housing will tell you if an impulse recorded by the microphone is an actual acoustic event, or if that is a shock, mechanical shock to the microphone that will be interpreted by the microphone as a peak. Removing those peaks is of highest importance. And then finally, operator detection sensor. Remember again, the example I gave with the X-ray exposure. Well, if you leave your X-ray exposure dosimeter in the X-ray room, you will get off the charts reading in post-processing. Equally so, if you leave your X-ray dosimeter in the break room, and you will have no exposure during the entire day. It is therefore critical to be able to tell whether the operator is wearing the dosimeter or not. In the Svantek dosimeters, you have an operator detection system that can tell you whether the dosimeter was worn or not. This is also done through measuring the vibration on the dosimeter. So if the operator is walking around with it, the dosimeter is moving around, so it feels that it's being worn. For a stationary worker, let's say we have a worker that works by a desk, he does not move around. He will still move his chest when breathing, and the sensor here is so sensitive that it will tell whether the chest is moving or not, and will be able to distinguish if it's worn or not. But if I take my dosimeter and put it in the break room on the table and I'll leave, well, that's when the dosimeter will start alerting that I am not being worn, and you can now do that distinction in your post-processing session that during this time the dosimeter was not worn. So we've talked about the importance of validation. We've talked about the ISO standards requirement that the validation has to be performed. Well, how important is it really? At Svantek, we decided to see. So we performed a test, we performed a survey where we, so to say, created one supervised and one unsupervised dosimeter. As you can see on this next picture right here, we had one of our workers that works here at Svantek in the mechanical shop were two dosimeters. One dosimeter was assumed the supervised dosimeter. It was worn during the entire session. The wearer was briefed and was cautious with it. Supervision was enforced, meaning that he was supposed to perform the measurement as if he was supervised, and he was supervised when it comes to that dosimeter. And it was ensured that the dosimeter was not tampered with. Now, the unsupervised dosimeter, the red one here, was a dosimeter that he could do essentially what he wanted with. He was told to wear it, he was told that it should be on, but that was it. So what was the result of that study? Well, it was a huge difference. The supervised right shoulder dosimeter gave a dose of 7.3% over the entire course of the day, meaning that a conclusion here would be, you're fine. We do not have to perform any extra safety measures for noise exposure, while the left shoulder, which was exposed to a lot of disturbances, had a dose of 106.1%. So how can that happen? What can we do if we theoretically have the same measurements, because that was a whole day measurement, the same person wearing the same dosimeters, but we have completely two different conclusions. We're not talking about some slight drift in percentage. We're talking conclusion from the supervised dosimeter is you're fine. Conclusion from the non-supervised dosimeter is we need to do something about this noise. What can you do if you don't have the ability to supervise? Well, you need to validate. So again, walking through the different methodologies that we pointed out that we can do with these dosimeters. The first one is removal of non-valid noise sources. Thanks to the audio recording feature and the supervised validation tool, you can easily listen to the different noise sources during the post-processing session and exclude by just one click of a mouse the sources that you assume are non-valid and do not have a place in your noise survey, and leave those that are valid. On top of that, you can have a frequency analysis of that signal. So if you are in a situation where the customer does not allow recordings to be performed, whether this is a union question or a safety concern question, or simply they don't want to be recorded, you can do a frequency analysis of that signal, and you can be able to at least distinguish which frequency was the most dominant one. If you have a lot of frequencies within the range of human speech, you might be able to tell that this was people speaking and not an actual sound source. Obviously, it's much better to just listen to it. In our survey that we did, the survey that we're presenting now, it was found that the non-valid noise sources of the 8-hour measurement period were only accounted for 2 minutes and 30 seconds and only accounted for 1.3% of the dosage. That was our conclusion, that this was not a major impact. What is a major impact are the mechanical shocks to the microphone. The Svantek dosimeters are equipped with MEMS microphones that are covered by a lifetime warranty. So the lifetime warranty will allow you to pretty much expose this to a lot of shocks without your microphone actually breaking. But remember, every time you have that kind of a shock, every time you expose that kind of a shock to your dosimeter, it will interpret that as a very high vibration or a very high acoustic impulse. Now, if we leave these acoustic impulses in our noise survey, I can assure you that we will receive a measurement level that is way beyond what we're actually measuring. Now, in Svantek dosimeters, the microphone and the accelerometer, the vibration sensor, yes, they are independent of each other. So it doesn't matter that there is a peak. It could be no peak. If the vibration is picked up, it will mark in the logger. And using the validation tool, you will be very easily and fast able to just remove that from your survey. In our survey that we performed, we found that during those 8 hours, we had a duration of 10 seconds when we had those impulses. But those 10 seconds, so a percentile of the entire measurement time, gave 87.6% of the dose contribution. So almost all of the dose contribution of this measurement was created through those impulses. And this is how the dose measurement works, because it's an LAV level. So if you bump this, that will have a huge impact on your dose, on your expected dose. Now, why is this so? There is a very good reason behind it. And the reason is that acoustic trauma, as seen in movies, you know, the movie where something explodes and the hero of that movie gets up from the ground, dusts himself off, and he has this ringing tone in his ears. He has this ringing sensation. That is acoustic trauma. That is a very fast, very high pressure level that has very big impact on your hearing and can damage it instantaneously. It is not the same as occupational noise exposure over a long time, where the long exposure over a very long time damages our hearing gradually. No, it is an impulse that will damage it instantaneously if a certain level is obtained. Now, this is why the standards that we use to calculate those really take into consideration these kind of levels and make sure that they really raise that dose. But often, more often than not, you will take your dosimeter, you'll put it on the table, you know. That itself, that is just a shock, you know. I have my phone, I put it like this. This is a shock. The microphone picks it up as a very high noise level, while the rest of us, if we don't have the vibration sensor, we'll just think, oh wow, so there was a very high noise impulse here. Good to know. This is going to be dangerous for the people exposed, right? This is why removing removing the impulses is very important, and our service shows us. And finally, as you can see here, operator detection. So here the dosimeter is left laying on the CNC machine. Thanks to the operator detection system, we can tell whether it was worn or not. Again, in our survey, it's shown that this was left for 1 hour, and it gave a dose contribution of 30.7%. And this works both ways, right? You can leave and forget your dosimeter inside the break room, inside of your locker, wherever, and suddenly you have a 0% noise exposure because the level is very quiet. Or you leave it next to a very loud source, like in this example, it was next to a sound speaker, and it raises the dosage. Doesn't matter which way it pulls. What matters is that you are assuming that this level that was recorded during the time where it was not worn was the actual exposure of noise on that person. This is not true, therefore it must be excluded. The Svantek operator system gives you that ability to exclude that. So the conclusion of this study is pretty impressive. An unvalidated, unsupervised measurement gave 106.1% of a dosage, okay? 106.1, meaning that a conclusion here would be, we have a problem, we need to do something, either hearing protectors or nothing, or something else, yeah? Now, the same measurement validated with validation tool gives 4.3%. So if we remove the shocks, if we remove the non-valid data, if we remove the data gathered when this was not worn, we get a dosage of 4.3%, all right? 4.3%. Now, the right shoulder that was supervised was not validated, so not validated but supervised gives 7.3. So you see that the validation can give fruit to the whole concept of unsupervised noise dosimetry sessions. And we have to face it. We don't have time anymore to always be on point, to always watch the subject that is being put under noise exposure measurements. We can't follow them around, making sure that they do everything as they should. Especially in COVID times, we saw that there were times where people would just take their dosimeter and ship it off to a facility and perform that measurement. Without the validation, we do not know what we have, all right? Without the validation, it doesn't really make sense to purchase expensive engineering class equipment as the dosimeter is. Just use an app or something, because it is equally invalid if you don't validate the results. But with validation, we can make sure that the unsupervised way of doing things has at least a higher reliability. We can make sure that we remove the most damaging artifacts like the mechanical shock. We can make sure that the dosimeter was actually worn. We can get the acoustic data. We can see what the audio recording will tell us. Now, you might ask yourself, so is this something that is complicated? It does sound complicated. How do you perform a validation? So I'm going to show you just how easy it is. Software I'm going to be doing a demo on is the Supervisor software. This is a Svantek software for health and safety professionals. This is a Svantek software that we use for pre-configuring the devices and for post-processing generated reports. If you already have this software, there's a very easy way to switching between Supervisor Advanced and Supervisor Lite, or we just use it Supervisor and Supervisor Lite. Supervisor Lite is for the less experienced users. Supervisor Lite is for the users that want to use the validation tool. Supervisor Lite has been created with the thought of being intuitive, easy to use, etc. And obviously, it can be downloaded free of charge on our website, svantek.com, and just go to the support tab, software downloads, and you can download it. Even if you're not the current user, you can download it and use our demo files to just see how it works, see what it does, see how a validation can be performed. So I'm going to go ahead and do a quick demo now on this software. So just like here. I'm gonna assume that you guys can see my new screen, the Supervisor software. So the Supervisor software, as you can see here, this is the pre-configuration stage. I have my K5 dock connected here with two dosimeters. This is what we can see on this screen right here. I can go ahead and change depending on what kind of configuration I want to perform. I will not be going through this now. There are tutorial videos, so if you download it here, just direct your attention to the right top corner, says need help, check out our tutorial videos. Depending on where you are in the software, that will take you to a tutorial video that will show you how to perform these things. What I want to focus on is the validation tool. So I want you to focus on, guys, on this value right here. Per OSHA HC, this 7-minute and 4-second measurement gives me a predicted dose of 125.7%. So if this was not 7 minutes, but 8 hours, but the level would be exactly the same, I would receive 125.7%. To begin our validation, we just double click on it and make sure that we mark the Use Validation Tool tab. This will open the logger view and it will show us all of the events that we talked about. So we have 3 types of events right now. We have the audio event, we have the high vibration event, and we have the no operator detected event. I do not know if you will be able to hear it because unfortunately this platform does not allow to share your computer audio, but maybe you will be able to hear it through my speakers. So my first event is an audio event, meaning that it was triggered because it exceeded a certain threshold that I set. Since I'm measuring it according to OSHA here, I think I set that threshold to 85 dB. You can freely set whatever you want or perform a continuous measurement. So I'm going to go ahead and listen to that event. I'm not sure if you were able to hear that, but what it sounded like was a drill or a jackhammer. So I'm going to assume that this is a correct event. I will move on. So nothing is removed per default. This is why it's marked in green. We accept this. I move on to the next event and listen to that. Again, I have the same noise of a drill hammer. So I'm assuming this is correct. Now, the next event I see is a high vibration level. High vibration level, as we mentioned, is a level created by an impulse to the microphone. So without further ado, I will just remove it by clicking here. Now, obviously, this is a 7-minute measurement, meaning that I can do this validation pretty quickly. But if you will have an 8-hour measurement, maybe you'll have 25 of these high vibration events, and you don't want to remove everyone for itself. So you can use this function here by just choosing high vibration as a filter for what kind of event you want to look at. You click select all, and you can see the red event is the one that we already removed, but we have the green events, those that we have not removed. I'm gonna go ahead and click the red button again to remove those events. Those events are now gone. We now go back to all events and we'll just take a look at this one. So this is another audio event. Obviously, I've done this demo before, so I know a little bit about it. This is, and we're gonna go ahead and listen to this. I don't know if you were able to hear that, but this is now music. So this is, I'll go ahead and assume that this is invalid noise. This is my opinion. Obviously, as a health and safety professional, you will make your own opinion and you will make your own distinguishment whether it is valid or not. So I'm gonna go ahead and remove this. And then finally, we have the no motion event. And you see this whole marker here shows that between the time here and the time here, there were no motion, meaning there were no operator detection. Nobody was wearing this. So I'm gonna go ahead and remove that. Now, if I was there or I was informed by someone that between this time and this time, something invalid happened as well, I can just go ahead and using my mouse, mark that and go ahead and remove that as well. And this is how easy it is. It will summarize all the events recorded by the dosimeter, and it does that itself. You don't have to do any big pre-configurations. And you just go through using this interface, remove whatever is invalid. And once you've done that, let's go ahead and recalculate the noise dose. And it now says 70.1%. Remember, before we did this, it was 125.7. Now, post validation, it is 70.1. So again, this shows you the difference a validation can make. And obviously, it will often work in the other direction. You will end up with a higher level than before, or I mean, it depends on the situation, but it will give you a reliable result, and this is what we're looking for. In order to be able to make a conclusion, in order to be able to make a reliable conclusion based on this equipment that is a high cost equipment, you know, dosimeters are not cheap. This is not something you buy on Wish or AliExpress. This is a expensive piece of equipment, so you need to take that extra step and really make sure that you have performed a reliable analysis, and you cannot do that without some validation of the result. So that was the quick little demo, and again, as I mentioned, all the tutorials are available on YouTube. So if you find some functionalities of this unclear, or you want to just see for yourself what this is like, you can find all our tutorials on YouTube, and just go ahead and deep dive into the Supervisor Lite software. Now, finally, we do sell these as part of our business. That is really what we do. So I want to go through the tools available, obviously plug our dosimeters a little bit. So in our opinion, and objectively in my mind, we sell the best dosimeters on the market right now. The SV104A and SV104BISs are the most rugged, the most compact, and the most reliable dosimeters on the market. We use a patented MEMS technology for our microphones, meaning that our microphones are extremely sturdy and shock resistant. Obviously, on the kind of devices, the microphone is usually the part that is the most expensive, and it's the most expensive to replace and repair. Now, we're so sure of this patented technology that we give you a microphone lifetime warranty. So on top of the 3 years warranty that you receive on the dosimeter, when you purchase it, you have a lifetime warranty on the microphone. So if 5-6 years from now the microphone somehow stops working, you will get a replaced one from ourselves with a calibration certificate. Obviously, we will not tolerate foul play. So if we get a microphone that has markings of being punched with a hammer, we will raise questions. But this technology has been extremely well received worldwide, and helps to get valid results and very reliable results in all of the different parts of the world. Now, a cool thing about the dosimeters here are the Bluetooth functionality. So our SV104A and SV104BIS dosimeters have Bluetooth. This helps you as a health safety professional that is on site to watch over the performance of that dosimetry session. What does that mean? Well, you can, without actually approaching the test subject, the person wearing the dosimeter, just connect to the dosimeter and see the current levels, see how long the measurement has been running, see how long the person was not wearing the dosimeter, because we gather that data in the app as well, see the different alarms that have been triggered or have not been triggered. You can do all of that without actually having to interact with that person, which is obviously advantageous when considering that you should try to limit the artifacts, the false noise contribution, as much as possible. If you approach him and you need to read off these values from the screen, you will now have to click on it. That will be an impulse per se, and you will start to falsify the results. Both of these have an 8 GB flash disk integrated into themselves. This means that you could perform a dosimetry measurement for 3 years in a row, and you would not run out of memory space because of the space. Obviously, a little bit different if we're measuring audio recordings. Audio recordings tend to need a little bit more space, but 8 GB is a lot, and you will be able to perform that measurement without having to worry that you do not have the storage capabilities. For the SV104BIS, we have the ATEX IS certifications, so they can be used in explosive environments such as mines, oil rigs, fracking sites, etc. Another thing to mention here is that the battery time on these is around 45 hours. So together with the very big memory, the idea was that this kind of dosimeter can be used for a full week of measurements, so 5 times 8 hours, without running out of memory or running out of battery. That is the idea here. For the dosimeter that is strictly safe, we do not have a USB interface, so you will require a dock like this. They are sold in five slot dock, or they are sold in singles, a dock like this. Thanks to this, you can have that fast charging and fast data transfer. You can transfer data from all the different slots, so not like our dear friends as Casella, that they have only one slot where they can transfer the data from. You can do it from all the 5 slots here. It is Wi-Fi ready, and in the future it will be a cloud-based system, so you will just put your dosimeter on your dock and that will upload it straight to the cloud, where you can access your data wherever you want. And we have a lot of future dosimeter applications that we're getting ready for. We are working on a new application called the Assistant 3, which will not only allow you, as on the picture here, to read off the values and just turn off or pause or start the measurement, but you will also be able to reconfigure it using the Bluetooth app. Now, finally, I want to just spend a few minutes talking about the MEMS microphone technology that we're using. So Svantek MEMS microphones are basically unbreakable, mechanically speaking. They're very sturdy, and thanks to that, we are able to do that lifetime warranty because we know that they will survive. The difference between a MEMS microphone and condenser microphone in terms of how functioning is they're pretty similar. It is just that the MEMS microphone is in micro scale, and this micro scale makes it very much a lower power consumption device than a condenser microphone. But most importantly, it is the durability of the instrument. A condenser microphone, as you can see here, it will have a diaphragm right here, so it will have a piezoelectric material that is just a membrane. If that kind of membrane falls from a height, it is punctured, it is damaged, the microphone is no good anymore. This is not the case for MEMS microphones because the membrane is extremely small. It is hidden inside the sensor chamber, and it's extremely small, making it extremely durable. It has higher stability because it cannot be disturbed by radio frequency interference or electromagnetic interference, and it is environmentally resilient, so it won't, from usage outdoors, it won't get all rusty and unusable. So these are the very good things about it, and obviously the sturdy mechanical shock will be something that we do as a setting tool all the time. So as main features goes, patented MEMS microphones, innovative features that no one has, audio recording, operator detector, and mechanical shocks, things that you really need, and an all-around champion for all. Thanks to the Supervisor Lite software, it is easy to use. You do not need to have a bunch of knowledge about dosimetry sessions before. We will walk you through it. We have the competency here at Svantek. We have the YouTube tutorial videos to walk you through your needs, but also you can be sure that this is used by the best, as in our initial screenshots or the slides from this presentation. So we're talking NASA, we're talking ESA, we're talking Chinese Space Agency, but we're also talking nurses in Connecticut, USA, that barely know how to use a computer but can still get around using our dosimetry, our dosimeters. And with that, I'd like to thank you all for your attendance today. It's been a pleasure presenting for you. Thank you to our Svantek UK team for arranging this. Thank you all for your time and your patience today with us. And if you have any questions, we're very happy to respond to them. You can email them into sales@svantek.co.uk, and we will get back to you. And as mentioned by Aaron initially, the online shop of Svantek UK and Axsoft now offers a 10% discount on purchases with a code from this webinar. So again, thank you very much for your attention. Thank you very much for taking the time to join us today. And if you have any questions, feel free to send them to us, and we'll get back to you as soon as we can. Thank you.